Hi everyone, this is lesson 2.1. We're going to do an introduction to monomials, polynomials, degree of a polynomial, just some basic operations with polynomial. First, we need to talk about some definitions. So a variable is a letter that represents a number. I'm sure we've seen variables before, so I'm not going to get into that in too much detail. We've also briefly discussed what a term is, but we're going to talk about this again. A term is a combination of variables and numbers. We sometimes call these numbers coefficients. Terms are glued together by some specific operations, specifically brackets, exponents, division, and multiplication, and are separated by addition and subtraction. We saw this in our order of operations lesson in Unit 0. So, for example, if I were to ask you how many terms are in this expression, x plus 5y over 10, the answer to this is there is one term here. And the reason there is one term here is that the top is glued together by, I call these implied brackets, but they're all glued together by being in the numerator, and the numerator is divided by 10. So actually the glue here is division. And in fact, if I were to write it in a straight line, instead of having a numerator and denominator, I would have to put brackets around the x plus 5y, so I can tell that this is all glued together as one term. Now, I can actually change this into two terms if I write x plus 5y over 10 as x over 10 plus 5y over 10. These two items are the same, but on the left-hand side we have one term, and on the right-hand side we have two terms. It's important sometimes to know how many terms are in an expression so that we can manipulate it more easily. Okay, I've used this word algebraic expression already a few times. What is it exactly? An algebraic expression is a collection of one or more terms. Now, if I look at this example, I have 3x squared minus 2y plus 4. This is an example of algebraic expression, and this algebraic expression has three terms. Okay, the terms are 3x squared, 2y, and 4. And we can see that they're separated by subtraction and then addition. What I also wanted to talk about, what I wanted to do here is name a few things. So we have numbers in front of our variables. Maybe first let's state what our variables are. Our variables in this case are x and y. And they are raised to the exponents two and 1, respectively. So I know when nothing is there, what is implied is that the exponent is actually 1. Now, what I want to draw your attention to are the numbers in front of the variables. So the number 3 is what we call a coefficient. It means it goes before and it multiplies the number, the variable x. If I asked you what the coefficient of y is in this case, the answer to that is actually not 2, but -2. Okay, so we keep in mind we always keep the sign as part of the coefficient. So -2 is the coefficient of y. And finally, this number here, the one that's all on its own, the one that isn't multiplied by a variable, we call this the constant term. Okay, so just so we know sort of the anatomy of an algebraic expression, so when I use these terms, these words, no pun intended, if I use these words, you guys know what I'm referring to. Okay, so you may have heard these terms before: monomial, binomial, and trinomial. Very simply put, a monomial has one term. A binomial, like a bicycle, has two terms. A trinomial, like a tricycle, has three terms. And a polynomial has more than one term. Okay, so a binomial and a trinomial are examples of polynomials. So now that we've gone over some definitions, we have to learn something new. Or actually, sorry, one more review item. So what are like terms? We have like terms when we have the exact same variables raised to exactly the same exponents. All right, so let's do an example. So if I have 4x to the exponent 3, any other coefficient in front of a variable x to the exponent of 3 would be a like term. For example, -4x to the power of 3 is a like term. So is 3x3 or 1/2 x3. Okay? As long as the variable is x and the exponent is 3, the terms are like terms. For unlike terms, let's say again I start with 4x3. Well, something like 4x squared is not a like term. Or if I had 1 over 4x3, that's not a like term, because as we learned last time, this would actually be 1/4 x negative 3. That's what we learned last unit. Okay, so let's get into something new. So in this unit, we're going to be asking you what the degree of a monomial is. So what is degree? Let's write the definition down, and then we'll do a few examples. So the degree of a monomial is the sum of the exponents of its variables. So just leave that there, and we're going to do an example. It'll become more clear in a minute. And the degree of a polynomial, so remember, polynomials have several monomials in a row. So what you want to do is in the degree of a polynomial, it is equal to the highest degree of each individual monomial. So what I do is I find the degree of each monomial in the polynomial, and then I just take the highest one. Let's do some examples, because that was probably a little bit wordy. So if I have the monomial 4x cubed, the degree is the sum of the exponents of its variables. So I see here my variable is x, my exponent is 3, so my degree here is 3. In my next monomial, I have 3xy, and we know that the exponent, when nothing is written there, is actually 1. So I ignore the coefficient of 3, and all I do is I look at the exponents, and I sum them, I add them together. So the degree of this monomial is 2. In the next case, The degree of my monomial is 3 plus 1, which is 4. Now, in this last case, this is technically a monomial. It's 7, but I have no variable. So what I can think about is, I can even just write sort of a ghost variable in there to help me. I know x to the power of 0 is the same as 1, so I can think about it this way. If I have no variable, the degree is 0. So a common mistake here is guys think the degree here is 1, but it's actually degree 0. Now for polynomials, we said here it's equal to the highest degree of each individual monomial. So what I have to do is break up the polynomial into its monomials, and here we have 2 monomials. And I have to look at the degree of each. So I can see that the degree of 6 squared is 2, the degree of 3x is 1, and all I do is I simply take the highest one. So in this case, the degree is 2. In my next example, I have 3 monomials. And remember, anytime nothing is written, there's a 1. So my degree is 5, 5, and 2. Now, when the degree between 2 monomials is tied, and it's the highest one there, it's technically the highest degree. So even though it's tied, the answer here is 5. All right, so how do okay, in this monomial, the degree is obviously 6. Here, I actually have to use my exponent laws from Unit 1 to help me. So I know that actually if I simplify this, this becomes negative 2 x to the power of 6, y to the power of 1. And if I add those two together, I get 7. The degree here is 7. I'm going to simplify the last one as well. 9a squared b3 c4. That has a degree of 9 plus 7, a to the power of 6, b to the power of 1, and a cubed, b cubed, c cubed. So again, we're tied for 9, but 9 is the highest, so we write that down. All right, so next what we're going to do is just a quick reminder on how to simplify a polynomial. So basically, to simplify, we identify and collect and combine like terms. So we said like terms were exactly the same variables raised to exactly the same exponents. So I'm going to do an extra line here. You don't have to do this line in your work, but what I like to do is I like to write a line that places my like variables next to each other. Now remember, the sign always travels with the coefficient, is part of the coefficient and always travels with the term. So in my next case, I have 3 plus 3y subtract 4y. So I'm going to write plus 3y subtract 4y. Don't forget the subtract. And I have negative, or subtract 10x, subtract 3x. And then I can combine these terms by looking at the coefficients and combining those. So I add 4 to negative 2, I get 2z minus y minus 13x. So I think this is review. Let's do a couple more questions. So here I can see my y squared subtract 5y squared will be negative 4y squared plus 3y cubed. They're like terms, so I can add their coefficients. Okay, so in this question, we're being asked to simplify first, then evaluate. Evaluate meaning I'm going to substitute 3 in for y. So in my in this example, what I'm going to do is combine these. So I have negative 6 subtract 9 subtract 16. So I know that this expression is equal to negative 16y. And when y equals negative 3, I can write negative 16y as negative 6 times negative 3, which is 48. So I could have subbed in the y equals 3 right in the beginning and then added them together, but that's not what the instruction is asking me to do, so I did it. I simplified first and then evaluated. So let's do that as well here. So I have negative 3m squared subtract m squared minus m plus 3m is 2m. And then when I sub in m is 0.5, I'm going to write that as 4. Negative 4, 0.5 squared times 2, 0.5, which is negative 4 times 0.25, and 2 times 0.5 is 1. We actually end up getting negative 1 plus 1, which equals 0, believe it or not. Okay, so let's do a little bit of algebra now, where we're writing an expression for each perimeter. So here what we want you to remember is that when I use these dashed lines, it means that these lengths are the same. So I'm going to use P for perimeter, and I have 3 x's followed by 3 y's. So my perimeter in simplified form is 3x plus 3y. Let's look at the next one. So for the next one, I can see that these lengths are y. Those two lengths are x. So in my perimeter expression, I'm going to write this as 2x plus 4y. So I always want to combine like terms. All right. Write and simplify an expression for both the perimeter and the area. Okay, so the perimeter isn't so bad. So all the length 1 dashes are e. Okay, so I know that my perimeter is going to be 4 e's, and then I have 1, 2, 3, 4, 5, 6, 7, 8 f's. So it's 4e plus 8f. Now, I'm actually going to copy and paste this over here again. Okay, and we can put that back. Okay, and what I want us to do is figure out the area. Now, there are many, many ways to do this. Okay, but what I would like us to do is separate this into 3 rectangles. So I'm going to make this one here one giant rectangle. Okay, and I'm going to cut the other 2 areas into 2 smaller rectangles. Maybe what I'll do is make, so that'll be one of our rectangles. And then we have 2 rectangles here that have the same size. And I know that because the side lengths are the same. Okay, so let's look at area of pink. I find the area of pink, or I find the area of any rectangle as length times width. So I know this is E and this is F, so the area is E times F. Now, if I look at my yellow rectangle, okay, again, I always know that the area of a rectangle is length times width, and I know this length here from here to here is F. Okay, but now I want to know the length across. So what is this longer length of the yellow thing? So I can see that here, this is length F. Here, this is length F. And actually here, because of this measurement, this is also length F. And I know that if I were to write this as F, or I know if I consider just that longer length, it will be F plus F plus F, which equals 3F. So the area of my yellow is going to be 3F. Now my total area is going to be one pink rectangle plus another pink rectangle. Oh, sorry. The area of the yellow rectangle is 3F times F. Okay, and we know from our last unit that the way we combine this is 3 f to the power of 2, right? Because f times f is the same as f squared. So my total area, EF and EF are like terms, so it's 2EF plus 3F squared. Okay. Now, the rest of this actually is some extra practice. So I'm going to go through this quickly, but I want to make sure you guys understand how to do number 13. So let's go through these ones a little bit quickly and we can get to the end. So I know the degree of this, 4, 3, 2, 0. My degree of this polynomial is 4. It's the largest number. 6, 8, 0. We've got 8 as the largest. I'm going to rewrite this as 2 times x, 8, y. And this is 9, 8, and 0. So my answer here is 9. All right, so the next one says simplify. So now what we're going to do is look at the operation in front of our brackets. So here I have a plus 1, and actually in both of these cases the brackets don't do anything. Okay, so all I do here is I remove the brackets, and in essence, if you remember, the word is distribution. We're going to distribute the plus 1 to everything inside the bracket. So now I'm going to collect like terms. So I have 3xy subtract 5xy, that's subtract 2xy. And I have negative 2 y squared, so I'm on the negative 2 floor, and I go up 7 floors plus 5y squared. Now here is where we have to be really careful. So I have a positive 1 here that I distribute, which has no effect really. But here I do have to be careful in subtracting the numbers by distributing the negative 1 to every term within that bracket. So for the first bracket, I basically just copy and paste. But in my second bracket, I have to make sure to distribute the negative 1 by multiplying each term inside that bracket by negative 1. Then I will collect like terms. So negative n subtract 7n is negative 8 subtract 8n. I have negative 8 plus 3 plus 5. The next one is very similar. Oops, I almost made the mistake. Okay, and now we will collect like terms. Negative 4t squared. Oh, those cancel out to 0, don't they? And then minus 7 plus 2. Okay, and don't forget, we can always check our answers. Okay, so I got this one right. All right, so for this last one, there are a variety of ways to do it, but the way I like to think about it is that the perimeter of any triangle is side 1 plus side 2 plus side 3. Now what I'm going to do is label all my sides. So I'm going to call this side 1, and side 2 equals 3x squared minus 5x plus 2, and side 3 equals 2x squared plus 3x plus 1. And here is my overall expression for the overall perimeter. So what I'm going to do is I'm going to substitute in 7x squared plus 4x minus 7 in for my perimeter. S1 is what I'm trying to find. It says find the missing side length. And then what I'm going to do is put in S2 and S3. So S2 is 3x squared minus 5x plus 2 plus 2x squared plus 3x plus 1. So now what I want to do is get S1 by itself. And the way I can do that is by copy and pasting 7x squared plus 4x minus 7. But then I'm going to bring all of these terms over across the equal sign. So I get subtract 3x squared plus 5x, subtract 2, minus 2x squared, minus 3x, minus 1 equals S1. And now I can just collect like terms. 7 subtracts 3, subtract 2, gives me 2x squared, 4x, plus 5x is 9x, minus 3, so plus 6x, minus 8. Sorry, not minus 8. I've got subtract 7, subtract 2, which is negative 9, subtract 1. Okay, so my missing side should be 2x squared plus 6x minus 10. And if I want to check to see if that works, what I can do is add up S1, S2, and S3 and see if I get the correct answer for P. Or I can just check my answer here.